Hello guys, welcome back to In 5 Minutes. In the earlier session, we have seen the bidirectional shift register and the unidirectional shift register. And this session, we are going to put further the universal shift register part. This shift register is called as universal because it can shift the data towards right as well as left. And along with these kind of operations, one more operation is there, which is nothing but the parallel loading. Okay, so it can take the data parallelly at the input and to this the output. So let us start with the shift register universal. Now first, the flip-flops used here are flip-flop A, flip-flop B, flip-flop C and D. These are all as D flip-flops. Okay, since the RS terminal says these are the SR flip-flops which are converted to D. Okay, so these are the D flip-flops and output of the particular flip-flops are shown here. So this is nothing but DQA, this is also QA. Okay, same way this is QB, QC and QD. Okay, so these are the outputs parallel taken here also. This will be requiring while we'll see the shift left, shift right and the parallel loading operations. Okay, so starting with the very first point, that is nothing but a mode control terminal is given here, which is very important. Now for this M can take two values. For let us say for M is equal to 1, what happens? So whenever M is equal to 1, what happens? See, in the external combinational circuit what we have drawn here for this section, clock 1 and clock 2, which are used for shift right and shift left operation respectively, whereas this is the matrix of AND and OR given here. Okay, so let us see how this combination logic changes as per the mode control. So I've set here M is equal to 1, so this one terminal is going to clock 2, so clock 2 will be activated by the AND gate number 10, whereas clock 1, which is connected to 9, is connected to M bar, so M bar is particularly 0 here, so this will be disabled. Along with this, you will see here M is equal to 1, so this 0 part here, one part will be connected here, 1 1 complement of complement, so 0 part is connected through this line through AND gate 9 as well as AND gate 1 3 5 and 7, which will be disabled. Okay, AND gates 2 4 6 8 will be enabled. Now which will enable us to parallelly load the data A B C D. So for M is equal to 1, that is nothing but the PIPO form, parallel input parallel output. Okay, so for M is equal to 1, clock 2, that is shift left clock, will be activated. Okay, but particularly in this session it is not going to work as a shift left because data will be set parallelly as we have taken the A B C D points outwards, so data will be set here. So suppose we have already connected A B C D to the particular combination of the data. Now what will happen for each clock combination? Okay, so for each way A bit is loaded through AND gate and this OR gate towards the D flip-flop. Okay, so data here it will be loaded, B will be loaded, C and D, and for each coming clock cycle you can take the data out. So here it will be QA, QB, QC and QD. So data will be out for each clock cycle. So this is how it works for the PIPO form of the universal shift register. Now let us see what happens when M is equal to 0. Now particularly M is equal to 0, shift right operation will be there. How? Let us see. So let us put M is equal to 0 here. So this will value after NOT gate it will become 1 and for another NOT gate it will become 0. Now let us see what are the combination changes here. So now parallel data will not be allowed. Let us see how it will not be allowed. First of all, M0, which is shorted to gate number 10. So M0 connected to 10 AND gate, so AND gate output will be disabled. Okay, whereas this M bar, that is nothing but 1, which is connected to 9, so this, let me cancel out this clock 2 and the clock 1 will be enabled. Okay, so through which it is connected to all the clocks of the flip-flop which are inside the register. Okay, now along with that, M bar, which is 1, which is connected to serial input, which is connected to AND A as well as the M1, but at the same time AND 2 is connected to M0, so 2 will be cancelled, same as that for 4, 6 and 8, and this automatically will not allow this parallel input to enter. Why? Because 2, 4, 6, 8, these are the AND gates which are connected for the parallel loading of the data.